Okay? The next one we're going to look at is ammonia gas. Now, this is a very common gas. We use this in fertilizers. And it has the formula NH3. So the central atom here is nitrogen. Okay? So, nitrogen is in group 5A, has 5 valence electrons, north, south, east, west. I'll pair up the north side there because it's always cold on the north side. So we're going to pair it up there. It's a cold day that I'm doing this, so it makes sense. 3 hydrogens, single electron, boom, boom, boom. And since hydrogen in the first row only needs 1 more electron to be full, so we form a single bond with these 3 right here. So the line structure looks like this. And the nitrogen then is our central atom, because all the other atoms are bonding to it. Okay, so how many sets of electrons do we have around that nitrogen? Well, we got 1, 2, 3 for the bonds, plus an unshared pair of electrons that makes that 4. So we have 4 sets of electrons. And that means then that the bond angle is 109.5 degrees. Now, how many bonds do we have? We have 3 bonds. And what's going to happen there is that if you imagine that tetrahedron that you saw and remove 1 part of it, then that shrinks to a smaller sized version of that, but it looks more like a pyramid than it does a tetrahedron. So the geometry for this is considered to be pyramidal. Never learn how to spell. I'll be in good shape. Pyramid. Now, here's the thing. I have seen, and rightly so, the prefix trigonopyramidal because most people think of pyramids as most likely a square base. Well, this would be an equilateral triangular base. So the term trigonopyramidal is more apt. I'm not going to put that in there. If you put it in there, that's fine. It's more correct than that, but we'll just think of it as just a basic pyramidal shape. All right, so we have 1 more to go. Oh, yeah, let's put this in our little chart that's like way back where. So we have 4, and anytime you have 4, the bond angle is 109.5 degrees. We have 3 bonds now, and like I said, this is now pyramidal instead of tetrahedral. Okay? Alright. Last one we're going to do is water. Very simple. So, what's the central atom here? Yeah, it can't be hydrogen because hydrogen can never be a central atom. Hydrogen can only bond to 1 atom. Central atoms can bond to more than 1 atom. So by definition, hydrogen is unable to be a central atom. That means oxygen is what we're going to put down first. And as we've done before, oxygen is group 6A, has 6 valence electrons, south, and I'll pair these up right here. And then we have 2 hydrogens. So we got a hydrogen here, and a hydrogen here. And we'll form our single bonds like so, giving us 8 electrons for oxygen and 2 electrons for each hydrogen. Yes, everybody's happy with their fullness. Like being Thanksgiving with extra helpings of electrons. Who doesn't love an extra helping of electrons? Yeah. Okay, so now let's get to the geometry stuff of this. How many sets of electrons do we have around the oxygen? Well, we got these 2 right here, and we got these 2 right here. 4 sets. So 4 sets of electrons. And anytime we have 4 sets of electrons, what is the bond angle? Yes, 109.5 degrees. How many bonds do we have around? Well, we got 2 single bonds. So we put 2 bonds down there. Now, it's not going to look like that because that looks like 90 degrees. It's going to look more like this. This angle right here, 109.5 degrees. What do we call that structure? If you said bents, oh, you're geniuses, just like the people who came up with it. Well done. You said bents geometry. That, ladies and germs, is how we use the VSEPR to identify molecules. What you're going to do is, there is a practice problem on the very beginning portion of this, right there. And you're going to take 5 molecules. You're going to draw the Lewis dot structure for that. You're going to identify the central atom. And then you are going to come up with the bond angle of the number of sets of electrons around the central atom, the bond angle, the number of bonds, and the geometry for all 5. All right? Have fun.